Hi, good afternoon, as it is now afternoon, and I'm going to aim to finish in time for lunch. So I'm Paul Schwarzenberger, Cloud Security Architect and DevSecOps. So I'm going to talk about how to take over a production system in the cloud. So this is based on some of the work that I've done with different customers over the last 4 to 5 years. So before I start, how many of you are working on cloud systems in some way or another? So it's probably about half of the audience. And then, of course, there's some who are but didn't want to put their hands up, so that's fine. So what I'm going to do in this talk is I'm going to give 3 examples of cloud security issues. And these are all issues which I've encountered, as I say, working with different organizations. I'm going to aim to do some, well, I am going to do some demos, and so we'll see live demos. So we'll see how they go. And then what I'll then discuss is why those issues happened. And then talk about how we could prevent them. And on the prevention, we'll look at not just sort of technical ways of preventing these types of issues, but also sort of organizational, cultural skills and training needs. So we'll look at that as well as the technical aspects. So the first issue that I'm going to talk about relates to identity and access management roles. So this particular issue and demonstration is with Amazon Web Services, AWS. That's not to say that AWS is any less secure than other cloud service providers, not at all. But I chose AWS because they are the market leader, and in fact there was a Gartner, latest Gartner Magic Quadrant came out yesterday or the day before with AWS at something like $20 billion revenue per year, compared with the next one, which is Azure at $4 billion per year. So they are by far and away the market leader. So I'm guessing of the people who put their hands up, probably the majority, I'm guessing, are probably AWS. So what I'm going to do is because I'm sure some of you are very familiar with AWS, some of you are probably not at all. So I'm going to give a little bit of an overview into the context before then showing how to actually take over a production system. So what I've done here so I hate to disappoint anybody, I'm not really going to actually take over a production system live. What I am going to do is to simulate what actually happened. So, okay, so first of all, let me just give a bit of a sort of introduction. Just make this a little bit bigger. So identity and access management is AWS's, as the name implies, it's their service for controlling access and authenticating and granting rights both to individual people and also to any other services, computers, or whatever that needs to do certain things within an account. So this is just an example. So this is my account, or one of my accounts. And you can see here that within identity and access management, you can firstly define users. So you can see here I've defined a whole load of users. You can define groups. So I've got various groups, associate users with groups. And then there's also the concept of policies. And as you might expect, policies give certain rights to do certain things within AWS. So that might be permissions to spin up a virtual machine, or it might be permissions to create a new user, or permissions for Alexa for business device setup. So they can be very granular or very broad. And all of them can be defined either through a GUI or in code through JSON. So a whole load of policies. And policies, as you might expect, can be associated with either groups or users. They can also be associated with roles. So roles is another concept. So roles, the idea of a role is it's a way of granting rights to a service principal. Could be a user, could be a group, could be a server, could be another AWS service. And when a service principal assumes a role, then according to what policies you've set, certain policies will apply to that role. And so if you have a look at a role, which I'll just choose fairly randomly, okay, CloudTrail, CloudWatch log role. So there's certain permissions associated here with policies, and whatever is assuming that role gets a session token, which is valid for a certain period of time, in this case, an hour. So that's sort of how all that works. So that's identity and access management. So that's just to sort of give the context. So one of the organizations I was working with, I sort of came in as a DevSecOps cloud security architect. And when I came in, at the point that I came into the project, there was already a production system that had been going for about a year. And that production system was used for various web applications. And although there was a strong security department within the organization, there hadn't been any real sort of detailed security analysis of the code. So one of the things that I did, I was embedded within the DevOps team as a security specialist. So one of the things I thought, well, I better do is take a look at the code. So I looked at the code, and one of the things which, one of the requirements is for some of the servers within Amazon, the production servers, to be able to do certain things within Amazon, like access S3 buckets, for example, for storage, or even spin up other instances, and so on. So to do that, the server needs to assume a role, which then has a policy associated to grant those permissions for a certain time, typically an hour. So I looked at the code. Right, let's look at the code. Okay, so that's, right. Make this a bit. Okay, so this is a sort of representative, well, this is pretty representative of what I found. I just took out a couple of details that might have identified the customer. So the first section says what rights. So this is a policy. So this policy says, at the top it says, I've got certain rights to do certain things, in this case on S3. So, this actually gives quite a lot of rights because you can list buckets, list objects, and you can get objects, and you can put objects. So you can do quite a lot with S3. And then you can't do it to all of S3, only certain named buckets. And you might think that I just did this as a demo and put like bucket -name -secrets, but actually that's almost what the actual name of the bucket was. It did have -secrets at the end. So just to help anybody who was looking for something. So what that did is give pretty broad rights to these particular buckets. And then, as well as S3, it also gives permission for EC2. So EC2 is Elastic Compute Cloud. So this is Amazon Web Services infrastructure as a service to spin up virtual machines. So you can see that actually anything is allowed. So that's not good security practice, obviously, to allow any action within EC2, and also any resource. And then as well as that, there was another policy which I haven't bothered copying, which allowed full access, well, not full, but allowed quite a lot of access to Route 53, which is Amazon's domain name service, certainly enough to create new records and delete records. So that was the policy. And then bearing in mind that a role gets to assume a policy. So if we have a look at the assume role policy, so you can see that here's the assume role policy that was on most of the production servers. So I'm sure we have some AWS people in the room, or AWS, people who have worked with AWS. So would anybody like to sort of have a guess or know what's wrong with this policy, or what the implication is of this assume role JSON associated with the policy? Go ahead. Pardon? Yes, so the wildcard, yeah, almost. I mean, so the principle, so the comment was, does the wildcard, the star, allow permissions to everything? Almost. I mean, this bit is the role, what's allowed to assume the role, and then the other thing that I just showed you was the policy, which is what the permissions are. So the fact that it says AWS : star actually means that any other AWS account whatsoever is allowed to assume this role and then gets the policy. Go ahead.
It doesn't specify what role you're allowed to assume. Is that the next thing, or is it just that it lets you assume any role?
Well, as you'll see in a minute, it allows anybody to assume this role, provided you know the name of the role, or you could guess the name of the role. It'll become a bit clearer when I demonstrate it. But yeah, so that's the problem. So I thought, well, this is pretty serious because, okay, the production AWS account is owned by this organization, but anybody else in the world could just set up their own AWS account, assume this role, and then get permissions on this account. So I thought, well, this is pretty serious, quite a high risk. So as you do as a security person, you sort of flag it as a high risk. And then I thought, well, I better fix it. So I created, because I was embedded in the team, I did the usual process, which was to clone the repository, create a branch. On my branch, I corrected it. And the correct role is shown here, which isn't very different. It's only about 2 lines of code difference. It says the principal, instead of being AWS : star, the principal is service ec2.amazon.aws.com. And the way that AWS interprets these assume role statements, that is not anybody's EC2, it's only EC2 within this particular account. So which was what was the intention, because it's meant to be a server in this account, assuming that role to do certain things. So that's the correct one. So I corrected that, and that's one of the easier fixes I've done. Literally, the fix itself took, about 5 minutes. And then, committed that on my branch, put it through the CI/CD pipeline, went through all the automated tests, then it got merged into the dev branch, and then that was all good. So then a couple of weeks later, I thought, I wonder if that's actually been promoted yet into production. So I checked on the production system, and it hadn't. And so I raised it as an issue, and then still nothing happened for quite a while. And that was nothing to do with this code. It was just to do with other factors. But it meant that although we'd fixed it in the dev branch, it never actually got into production. So I thought, well, this has really gone on long enough. I need to do something to actually get some attention, because even though I was raising things as high risks and critical risks, that was just being, unfortunately, not treated with the seriousness it deserved. So what I did then was, right, where's this? Hold on a sec. How do I get this? Help. There we are. Right. So what I did then was I got my own account, which I've just shown you. So this is my own account. And then now I'm simulating this. So I'm simulating what I did to simulate what actually happened. I've set up my own separate AWS account to simulate the production account. And there's no connection between these accounts. I mean, they happen to both be owned by me, but it could be anybody. So anyway, so what I did was I used my own account, and then this is what I did. So if I just, expand that a bit again. So so I'm logged into my own account. There was nothing to do with the organization that I was working with. So I just click on here, and then I can do switch role. So switch role. And then this now gives the switch role option. So all I need to do to switch role and then take advantage of that sort of code is to put in, because I've done this before, the name of the account, which is this, and then the name of the role, which is this, and then switch role. Okay, so now I've got into a completely different account. And you might think, well, that's quite hard to do because you'd have to know the name and the role. But on the other hand, you guys probably wouldn't because quite a few are good at enumerating things. And also, bearing in mind that what quite a lot of organizations do is to put a lot of their code onto GitHub, some of it in public repositories. And it wouldn't actually be that hard to find out the names. Or, of course, if somebody had left the organization, they could have a copy of the code base. Anyway, so I've got into the other account. So if I look at, if I look at users, for example, so I'm now in the other account, which simulates the production account, you can see here I don't have permissions. Well, this is what you'd expect because this is identity and access management, and the policies didn't have anything on it, identity and access management. So now let's look at some other services. So if I go into EC2, so we're in EC2 now, and you can see that there's no indications that I don't have the required permissions. So what I can do here is to go into running instances. So there's an instance running. So in this case, I've just created one instance, just as give you the idea. In the real example, there was about 50 production servers. So then, I can just highlight this, and then I could do actions, for example, terminate. So I could terminate that instance. And then if I wanted to spin up my own instance, which might, under my own control, I could do this. So I'm just creating a new instance now. And do this. So now I've just created a new instance. And then I can view the instances. So I've just shut down one instance, created my own new one. I did also, in the real case, there was access policies that allowed Route 53 changes as well. So you could have pointed DNS to my server, taken customer credentials, for example. Could have mined lots and lots of Bitcoin. So the possibilities are endless. So what I did in the real case was I didn't actually delete production servers, but I did get to that point. Took a whole load of screenshots, put it in a PowerPoint presentation, sent it to all the senior managers, and then it all got fixed in about 3 days, which was good. So that was the first issue. So from a technical point of view, as you saw, from a technical point of view, all the, let's go back to this. All that was actually wrong was 4 lines of code. So, this is just some screenshots of what I've shown you. So that's the incorrect one. This is the correct one. So why did it happen? Nobody admitted to doing this. They all said it was somebody who had left. It had been like that for a year or so without being noticed. Fortunately, I don't think any attackers noticed, as far as I'm aware. There was no evidence of that anyway. My guess is that the person who originally coded this, he wasn't a security person, and he probably just Googled assume role, came up with that code, and copied it because that was lower down on the search list. I mean, that's just a guess, but I expect that's what happened. So we'll talk a bit later about some of the things you can do to prevent people doing that sort of thing. We'll talk about that later. So that's the first issue. So I'm going to move on now to the second issue. So the second issue was the favorite topic of last year amongst cloud. Well, not cloud, just cloud, but data loss generally, and that's S3 buckets. So, there's been, particularly last year, and some this year as well, there's been loads and loads and loads of losses of data from S3 buckets. This particular example is Dow Jones, 2.2 million clients lost their information because of an AWS configuration error on S3. So we'll just take a little look at S3 and see how easy it is to misconfigure S3. So, right, so I've actually done this in my other account. Yeah, so if we go to S3 on my other account, right, so what you'll see is on this account, I've created, so S3 is simple storage service, so this is Amazon's, the way that you can store data in S3 in the cloud with Amazon. And again, just like the first one, this demo happens to be AWS. However, all the same sort of issues are there with Azure storage and Google storage. Anything can be misconfigured. So you can see here I've got two buckets. So I've got two buckets. And you can also see that there's this orange sign saying public. So and you can see that neither of these buckets are marked as public. Now, because of all the data losses particularly last year, Amazon they've upped the game a bit, well, quite a lot actually, with S3. So one of the things they've done is they've put this sign that says public, and then what the code does is to look at the permissions on the bucket, and if it's public, then there'd actually be an orange sort of symbol next to the bucket. So you can see here that, and also it says access not public. So they made it a lot more obvious through the GUI anyway. Bear in mind that quite often generally everything is coded anyway. So quite often the people who are actually writing the code for the infrastructure don't see any of these warnings because they're just coding, But anyway, you can see here that neither of these are public. And then you can see here that if I go into this bucket, so the bucket's called CPMS3, and if we look at permissions, you can see that the permissions are like this. So you can see that, okay, so my own root account does have permissions, which is what you'd expect, and then basically nothing else has permissions. So the public does not have permissions to list objects, to write objects, or read, or anything. So, yeah, so there's no permissions allowed, which is why it was not public. Okay. So, yeah, where am I? Right, so if we go back to the overview, so you can see that I've created a file called passwordfile.csv. So any of that you working quickly will have already downloaded this file, but maybe not just yet. So if I click on this, you can see that there's password file. So Amazon have got quite a helpful naming scheme so that you can get objects from S3 via the web. So if I go to, so I'll open this up in a new browser just to make it clear that there's no Oops. No, 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 no. What? No, 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 no. I don't want any of that. All right. No, I don't want any of that. Right. This is what happens when you do an upgrade just before demonstration. Right. Okay. I don't want to know about new things. Right. Okay. So, right. So Amazon, as I said, they've got quite a helpful, helpful sort of way of naming buckets. I could have just clicked on the link, that might have been easier, but I wanted to show it like this. So, HTTPS. So it's HTTPS, so it must be secure. And then, and then you put in S3 hyphen, then you put the region. So it's like EU West hyphen 1. Then you put Amazon.AWS.com. Then you put the name of the bucket, which is CPMS3. Then you put the name of the object. So this is password-file.csv. So do that. So I've just downloaded that file, even though the bucket was not public. So you can see here, I've downloaded this. Any of you that wants to download this, any of you who want to download this, can download it. Okay. So how come? Yeah. So why did that happen? Any ideas? We just. Pardon? Pardon? ACL, exactly. I knew there'd be, at least one person in the room. So, access control list. So you can have access control lists at the bucket level, but you can also have separate permissions at the object level. You can also have bucket policies, which are JSON-based policies. So if we have a look at, so although at the bucket level there were no permissions, if we then have a look, if we go back to the overview, and then have a look at the password file.csv, and then we look at permissions within that object, then yeah, you're absolutely right. There's a different access control list for the object that is greater than the parent bucket, and everybody is allowed to read this. So you might think, well, why would anybody ever configure anything like this? So at one of the organizations I was working with, a DevOps person created a public S3 bucket. So I said to him, you're not allowed to create public S3 buckets, make it private, please. I did say please. So he did, so he made it private. But when he made it private, I think that all he did was just make it private manually and left the ACLs of the objects as they were. This sort of thing can really happen, and it is very easy to misconfigure, particularly when, particularly when you're doing everything in code. It's a little bit more obvious through the GUI than in code. So that's the second issue, which is S3 buckets. So now let's just go back to the PowerPoint. So go back to the PowerPoint. And talk about next thing, which is keys in GitHub. So, as an illustration, I created a GitHub repository. So if I go here, oh yeah, I've actually got it here. So GitHub repository, oops, sorry, where am I? Yeah, here we are. Okay, so GitHub repository. So this is in my own organization, GitHub, and I've created a repository just so that nobody thinks I'm doing this on purpose. I called it insecure, just to sort of illustrate, how easy it is to, put keys into GitHub. So when I was at one of the organizations I was working with, I was at work, and fortunately, I had my email open, and it was 11 o'clock, it was whatever, and got an email from AWS saying somebody's pushed a secret key for this account into public GitHub. Luckily, saw it straight away, and immediately logged onto the console and deleted the key. So within a minute or so of receiving the email. Luckily, it was while I was at work looking at emails and so on. We then informed the developer, who I think actually by that time had realized what he'd done. So that was fortunate, but it's often the case that people aren't that fortunate. So for example, I'll just get rid of some of these things. Where's my... Yeah, for example, DXC, not to particularly pick on them because this can happen to anybody really. For them, it didn't happen during the week at 11 o'clock. It happened on Friday afternoon, unfortunately, and somebody accidentally pushed a key. By the time when they came back in on Monday morning, there was a $64,000 bill from people who had mined Bitcoins using their account. Fortunately also for them, well, fortunately for them, it was a development account, not a production account, so they said that there wasn't any customer data in there. So that's easily done. And I do have a confession to make. It's very easy to sort of say, oh, that developer's so stupid, how could he do that? But I do have a confession to make, which is that 2 weeks ago I did almost the same thing. That was with some Azure credentials. And fortunately, it wasn't to public GitHub, it was to a private repository within the organization in a private network, luckily. So any of you who have worked with code and Git, you can have variables files, and then you can have a .git ignore file that tells Git what not to commit. And what I did was to rename the variables file, and I forgot, because I was in a bit of a rush, I forgot to update the git ignore file. Accidentally pushed my Azure credentials, which were for my own account, not a company account. And fortunately, my co-workers didn't take advantage of it and mine a whole load of Bitcoins. I realized pretty soon and changed the password. But it really is very easy to do. AWS have got a repository called AWS-secrets, which is some code that can actually stop you from even committing anything with keys in, which might be worth looking at if you're working with AWS. So that's sort of I guess the third issue. I've also seen more slightly more subtle variants of this, such as not an AWS secret key being on GitHub, but a read-only key to an organization's GitHub. And one of the organizations I work with, one of their DevOps people had, in their own private personal GitHub repository, had that they just were using for testing, they'd put a read-only GitHub key to the corporate GitHub. So anybody with that could then access private repositories in the corporate GitHub, and within those private repositories, there was quite a lot of other keys which could be used to take over an account and do a lot of bad things. So yeah, it's not always quite as black and white as just the AWS secret key. There's a lot of information that can end up in GitHub, which is, as you probably know, now being taken over by Microsoft. Right, so that's the third issue. Okay, so what I'd like to talk about now, and do maybe a couple more demos of some of the things that you can potentially use to help prevent this. So first of all, why did these security issues happen? Well, typically, the organizations I was working with there are, maybe not necessarily 30, but 20 to 40 DevOps people and CloudOps people. I'm sure a lot of you have worked in an agile, using agile methodology. So typically, we have 2-week sprints, and within a 2-week sprint, you have individual stories. Each developer or DevOps person picks up a story, which might be to create a new feature, add a bit of security or whatever, and then starts work on that. Will create their own branch, potentially, implement it. It'll have to go through CI/CD pipeline testing, usually, but not always, and have to be reviewed by somebody else. But you can see that if you've got 30 to 40 people doing this every 2 weeks, and you've got maybe each one might pick up 2 or 3, 4, 5 stories in a sprint, that's 100 or more different changes that are going on. And any one of those could potentially include some of the errors that I've sort of shown you that could lead to compromise of a production account. So that's sort of part of the background. But then, what could we actually do about it? So as I mentioned at the beginning, there's several different approaches. There's technical approaches, and then there's the sort of training, cultural, organizational type approaches. And we need to use all of them. You can't just rely on any one of those. So on the technical side, some of the things that we can do are to implement policy as code, which can ensure prevention. So in Azure, you can use Azure policies, which can do limit what actions you can take. With AWS, you can implement organizations and service control policies, as well as IAM policies. Security tests in the CI/CD pipeline, security scans. So they're more on the detection side. And then you can do some enforcement. So if you detect something that's out of compliance, then actually go and remediate it. So let's have a little look at a couple of these tools, just to give you an idea. So what I'm going to use first is okay, so I'm going to use a tool. So I don't know if there's anybody from NCC in the room. Yes, so okay. And you're leaving. How can you leave when I'm about to demonstrate your tool? Oh, well, fine. What I was going to say, no, I'll still say it. The NCC have done very well and it's very good of them to open source their Scout2 tool. So let's have a go at using it. So what I'm going to do is type Scout2, and this is all on GitHub. So Scout2. Then I'm going to do profile, which this is just because I've got more than one AWS account set up. This just tells the AWS command line interface which account to connect to. So I'm going to connect to the same account in which I gave you the S3 bucket demo. So the name of my profile is just the name of that account, or close to it. And then just because you don't want to be sitting here for ages, and I know lunch is coming, and I'm nearly finished. So I'm just going to limit it to save time to one particular AWS service, rather than do a complete scan of everything. So what it's now going to do is connect to AWS and have a look at everything in that account within the identity and access management section. So it's running a whole series of tests, and I'm just overwriting this because I've done it before. So you'll see here that it's picked up under identity and access management a total of, there's 12 resources, 28 rules, and 8 findings. So let's have a look at some of those. So you can see here that I've just got a good snapshot of this particular AWS account. Red obviously means high risk. Green means it's well configured. Yellow is medium. Gray means it's not applicable or can't be checked. So, so I very quickly identified that there's a whole series of issues that could be improved with the configuration of this AWS account. That's not to say that, as good as this tool is, and it does similar tests for S3, EC2, and so on, you can't assume that because everything is green on this tool, everything's fine, because there's certain things it won't pick up. So, for example, this would have picked up the first issue, the IAM role issue. It wouldn't have picked up the S3 object ACL being public, because it doesn't go down to object ACL. So nothing's perfect, but it is a very good start, and it's largely based on the Center for Internet Security, CIS, benchmark for AWS. On the repository side, there are tools that we can use. So I mentioned before AWS secrets can be used to stop you committing code with an AWS secret key. But sometimes it's too late. What if you want to just find out what's there? So there are tools that you can use. So I'm going to scan the repository which I showed you via the web GUI earlier. So I'm just going to do git rob, because this is git rob, also on open source, analyze US spelling, and then the name of the repository. So I'm scanning GitHub, and what it's doing is it's looking at all the repositories. And the other quite nice thing about this is it doesn't just look at the repository you're scanning, but if you've got contributors to that repository, then it goes and looks at their public repos as well. So let's have a look at what we can see on there. So 9393. So if we just go to, localhost 9393. OK. So you can see that it has found various things. For example, it's found an RSA private key. There's lots and lots of private keys in GitHub, and this is one that I put there. But don't worry, I'm not using it for a SSL website. Also, it did also find the AWS secret key, and that is deactivated. If anybody tries to use it, feel free to have a go. Yes, so again, this is not foolproof. It won't find all credentials that are committed to repositories, and it will find some false positives, but it's a good starting point. So just going back to the presentation, which is now nearly finished. Well, close to being finished. Not quite. So we talked about some of the techniques we could use technically. Training is important. I've developed a training course for QA, which is GCHQ certified, but equally, there's so much training out there. I recently used a Cloud Guru for some AWS security training, which helped me. So that was very good. Equally, things like lunch and learns. So when I was working at some of the organizations that I was working with, I did sort of 10-minute WebEx, sort of 10-minute sessions at the end of stand-ups on a particular security aspect, like some of the ones I've just shown you, to all the DevOps. That was quite useful. So there's a lot that you can do. Culture, it's essential that senior management supports security and that prioritization, that security features actually get prioritized, because quite often the same people will be developing these as creating new features or providing performance improvements. And doing other things like GDPR compliance. So it's important to have a strong security lead that can fight for that priority and senior management support. And finally, organization. Separate security departments don't work with Agile and DevOps and cloud. I can confidently say that from experience. What happens is that these guys just get in the way of these guys, and they try and stop things from happening, and they don't, and it's just not effective at all. What is effective is embedding security specialists or training DevOps or developers to become security champions to take a lead in the team. So, for example, I every morning, not today, but other mornings, I participate in the stand-up. I'll report on my security stories, and I'll find out all the other things that are going on within the DevOps team. So if there's something I have a concern about, I will go and talk to the person. We all sit together, and we're all part of the same team. That works much more effectively than that. So as it's lunchtime, I won't take any questions with everybody here, because I know you all want to go to lunch, but I'm around the rest of the afternoon if anybody does want to ask questions. So thank you very much.